All right, class, here we have the second section of this unit on acids and bases, and this is about how to do pH calculations. Now, when I say pH calculations, that can involve doing pH, but it can also involve something called pOH. And we're going to take a look at these. You're going to want to have this list of equations handy when you have assessments, quizzes, and tests. Let's take a look at this. Now, this all starts off with the idea that water can ionize with itself. Well, what does that mean? Well, if you have two water molecules, they're going to bump into each other and transfer a proton. Now, because one of them is acting as a proton donor and one of them is acting as a proton acceptor, what we have is that the Bronsted-Lowry definition of acids and bases. Notice how the water turns into two different ions. We still have an overall neutral charge, just like we started, and we have a double arrow. This double arrow represents an equilibrium process, meaning that this process goes back and forth. In fact, it goes back and forth constantly in all water solutions. And we're talking on the order of like billionths of a second. So it's happening and unhappening all the time. Only a small fraction, about 1/10 millionth of the water will actually do this at any one time, but this is where we're starting. We also want to keep in mind that if I ever use hydrogen ion or hydronium, they are defined as the same thing. Now, when you do this and you do some math, you end up with what's called this equilibrium constant for water. Constant, W water. And it is the hydronium times the hydroxide. This value at 25 degrees Celsius is always 1 times 10 to the minus 14. These brackets represent molarity, concentration. So we have a molarity times a molarity, and that gives us molarity squared. When we do the measurements, we find that we have 1 times 10 to the minus 7, 1 times 10 to the minus 7. When you multiply them, you get 1 times 10 to the minus 14. So this is a constant value at 25 degrees Celsius for all water. Because these two values equal each other, we call that neutral. And we assign that the pH of 7. And that's why 7 is neutral. Because if you take the negative log of this concentration, in this case, 1 times 10 to the minus 7, you get 7. When these two ions, these two species, are in equal amounts, we have neutral conditions. And when does that occur? At a pH of 7. pH is defined as negative log of the concentration. Okay, so this is a pretty important page. Let's take a look at how to do this. Now, if you've had log experience in your math classes, you're going to find that this is pretty straightforward. You need to find the log button on your calculator. 1 times 10 to the minus 5, if we put that in here for the concentration, we're going to get a value of 5. Okay, let's do this. 5. Now, don't forget, negative log concentration. If I take the negative log of this concentration here, I'm going to end up with 11. You might see a pattern develop. When we have 1 times 10, remember it's got to be 1, the pH of the value is always the negative exponent. Here we do not have 1 times 10. So you're going to have to type in 2.8 times 10 to the minus 3 negative log of that value. And we you should get 2.5. Now, I don't know what type of calculator you have. If you're not getting this value, then you're not entering it into your calculator correctly. Most of the time, if you have a Texas Instrument or Casio, and they're the regular common ones, you type in the negative sign, then you type in the log button, and then you type in this value. Now don't forget, we've learned that times 10 is either in a Texas Instrument calculator, that EE button, or on a Casio and Sharp, it's going to be down by the decimal point, and it might be called EXP, or on newer ones, it's just going to be that button times 10 and then raised to the X. If you are not using your scientific notation button on your calculator, you're going to have a doozy of a time doing these calculations. Let's take a look at some other examples. Determine the pH of each of the following. Well, my concentration is 1 times 10 to the minus 2. I have a monoprotic acid. If you don't remember what monoprotic means, you're going to need to look at the video notes from acid-base lectures, and we're going to see that we're going to get a 2, and here we'll get a 3, and here we'll get a 5, and here we'll get a 4. Pretty straightforward. Now, I'm giving you straightforward values so that you can make sure you're typing them into your calculator right and getting them correct. We're going to start using not straightforward problems not too soon from now, so you need to take a look at that. Let's take a look at what this question is asking. It's asking for the concentration of the hydroxide, and no, we're given the concentration of the hydroxide. We need to determine pH. Okay? Now remember, Kw says that the hydronium times the hydroxide, and it's just getting worse and worse, isn't it? And I should have a plus sign inside the bracket. Okay? And this always needs to equal 1 times 10, that's another way to write, times 10 to the minus 14. So, if this hydroxide value is to the minus 6, that means the hydronium value is going to be to the minus 8. And that's going to give us a pH of 8. If my hydroxide concentration is to minus 9, that's going to give me a minus 1 times 10 to the minus 5 for hydronium, and that's going to give us 5. Here we can see this is going to be working out to 12, and this will work out to 7. If you have questions on this first part, make sure you email me. We can set up a Google Meet, but make sure that you're understanding how to do the calculator parts for this. Stay tuned for the next video shortly.